Hi everyone, I'm Rob Shapiro from Fitchburg State University, and this is the BACB's 5th edition task list item G-12, use equivalence-based instruction. So what is stimulus equivalence when we're talking about equivalence-based instruction? This is the emergence of accurate responding to untrained and non-reinforced stimulus-stimulus relations following the reinforcement of responses to some stimulus-stimulus relations. Sometimes we call this equivalence class formation. And essentially, a learner identifies or responds to relationships between two stimuli that have never been directly taught following the direct teaching of other relationships. So really, it's about getting learning to sort of emerge for free without formal training. There are three components of stimulus equivalence, and three things that we're looking for with stimulus equivalence. The first is reflexivity, which is essentially identity matching, which is A equals A, to be able to match that sample. Next, we've got symmetry, which is if A equals B, then B equals A. And third, the critical test for stimulus equivalence is transitivity, which is if A equals B and B equals C, then A equals C. And we'll get into each of the three of these in a little more detail. So how do we develop equivalence? So first, it's about reflexivity, and this is something that is directly taught. So we would teach A equals A, B equals B, C equals C, to get a learner to be able to match these things. This is essentially identity matching within the context of matching to sample. So in the three examples that we have here we have a picture of a truck, and we directly teach matching picture of the truck to the picture of the truck. Okay? Here we have the written word truck, and we directly teach the written word truck to the written word truck, so B equals B. Over here we've got the spoken word truck, which we directly teach matching to the spoken word truck, which is C equals C. So again, we're directly teaching this identity matching, okay? Basically, A equals A, B equals B, C equals C. Next, we move into the concept of symmetry. And symmetry, once we do some teaching, we get the symmetry to emerge without further training. So in this diagram, the arrows that are in white are the things that we specifically teach, and the arrows that are in blue are things that emerge without further training. So if we directly teach, if our sample stimulus is a truck, and we directly teach matching that picture of a truck to the written word truck, if then we show the learner the written word truck, and they're able to match it to the picture of the truck without prior training, without further training, we've got symmetry. So we've taught them A, the truck, equals B, the written word truck, and what emerges is the written word truck, B, equals the picture of the truck, A. Likewise, if we teach the picture of the truck to the spoken word truck, okay? We directly teach this, so we show a picture of a truck and they say truck, okay? And then when we say truck, they're able to match that to a picture of a truck without prior learning, okay? Now we've got symmetry. That blue arrow is a symmetry. We're directly teaching, in this case, A equals C, and what's emerging without further training is that C equals A. So that's symmetry. It's symmetrical. It goes back and forth. We can think about it that way. And then finally, the key test for stimulus equivalence is transitivity, which again, transitivity emerges without further training. So we can think of transitivity as if A equals B, which we directly teach, and if B equals C, which we also directly teach, transitivity then is that A equals C and C equals A. So we directly teach the picture of the truck, matching it to the written word truck. We directly teach the written word truck to the spoken word truck. Okay, if we teach those two things, what ends up emerging without further training, if we have stimulus equivalence, is the picture of the truck to the spoken word truck, and the spoken word truck to the picture of the truck. Okay, so we get all of this learning emerging without further training. So if we think about the power of equivalence relations, because you can look at that as, okay, that's kind of neat. That's an interesting thing that happens with stimulus equivalence, but kind of so what? But there's actually a lot of power involved in equivalence relations. Because once an equivalence relation has formed, any new member that is trained to be equivalent with an existing member gains equivalence with all members. So, in our example, a different picture of a truck trained to our first picture will also be in an equivalence class with the spoken word truck and the written word truck, right? So now if I take a truck that looks a little bit different, we had our picture was a line drawing of a box truck, right? But now I can take a line drawing of a pickup truck or an actual picture of a truck, right? Or an 18-wheeler, right? And if I teach that to any one of the members, if I just teach that to the written word or the spoken word, then the equivalence relations to all of the other members just emerge without prior training. And the bigger that equivalence class becomes, the more learning automatically emerges without prior training. Likewise, the spoken word camion, which is Spanish for truck, trained to the spoken word truck, will also be in an equivalence class with the picture of the truck and the written word truck. So we get all of this learning. The bigger our classes become, the more learning emerges without prior training. So there's a real beauty and efficiency to our stimulus class formation as a result of stimulus equivalence.